Hello everyone! It's me again, Teacher Joanne. This tutorial is for Statistics and Probability, a subject which is intended for grade 11 senior high school students in the Philippines. For today's objectives, at the end of the lesson, the learners will be able to convert a normal random variable to a standard normal variable and vice versa. Computes probabilities and percentiles using the standard normal table. For today's topic, we have standard normal distribution. So, what is a standard normal distribution? So, the distribution of a normal random variable with mean 0 and standard deviation equal to 1 is called a normal distribution. So, how does it look like? So, it looks like this. So, the normal distribution and the mean is equal to 0. The figure illustrates a standard normal distribution. The values along the horizontal axis are the values of the random variable z, which is the transformed value of x. So for a standard normal distribution, so the mean is 0. For a transformed one, so as you can see, there is a transformed value of x. So if x follows a normal distribution, then x can be transformed into a standard normal random variable through the following transformation. So where z is equal to x minus mean divided by the standard deviation. So if there are two values of x, so the formula would be x sub 2 minus mean divided by the standard deviation minus x sub 1 minus mean divided by the standard deviation. So in finding the area under the normal curve, we use the ztable. So the one on the left side has negative values. That means that is on the left side of the mean. And on the right side, we have the positive values, which means that is on the right side of the mean. So finding the area under the normal curve. So example, find the area below z is equal to 1. So since we have a negative here, the z table that we are to use is on the negative side. So to interpret, so it says below z is equal to 1, so meaning that is z is less than negative 1. So first locate the negative 1 under the z. Then next is locate the point 0, 0 on the topmost row since negative 1 has no decimal part. So the value corresponding to the intersection 0.1587 is the area below z is equal to negative 1. So to illustrate the area, so it says z is less than negative 1, so the area below z equals negative 1. So first, we have to locate the negative 1, then just trace it upward. And so the shading on the normal curve is to the left, since we are looking for the area below z equals negative 1. So this is how it would look like. So So therefore, the area below z equals -1 is 0.1587. So meaning the shaded area is equal to 0.1587. Next example. So find the area above z equals -1. So since we're still using the negative, still using the same side of the z-table. So since we're looking for the one above, so earlier we have below, so we use the less than sign. So here it's above, so we're using z greater than -1. So since the area below z equals -1 is 0.1587 as shown on the z-table, and the total area under the normal curve is 1, so the area above z equals -1 is computed as 1 minus 0.1587, which is equal to 0.8413. So why do we have to subtract it by 1? So we're looking at the right side or above the z equals -1. So as we know, the total area is equal to 1. That's why it's being subtracted from 1. So to illustrate the area, so we have the graph here. So same thing, we just locate the -1 and then trace it upward. So instead of shading on the left side, since it's below earlier on example number 1, and this time it is above, so the shading would be on the right side. So therefore, the area above z equals -1 is 0.8413. So that shaded area is equal to 0.8413. Let's have another example. So find the area between z equals 1.25 and z equals 1.23. So to write that, so we have z is greater than 0.23 and less than 1.25. So since those are positive values, so we'll be using the right side of the z-table. So first locate the 1.2 on the leftmost column and the 0.05 on the topmost row to locate the 1.25. Okay, so that would be 0.8944. Next, locate the 0.2 on the leftmost column and 0.5 on the topmost row. So the intersection is 0.05910. So z equals 0.3 is 0.5910. So since we're looking for in between or the area between, just subtract the two values. So that would be 0.8944 minus 0.5910. So the area is 0.3034. So to illustrate the area, so the area between z equals 1.25 and z equals 0.23. So the shading on the normal curve is between z equals 1.25 and z equals 0.23. So this is how it looks like. So you can just estimate the value of 1.25 and the 0.23. So that would look like this one. So the area is 0.3034. Okay, let's have another example. So find the value of A if probability of Z less than A is 0.9495. and probability of z is greater than a equals 0.0071. So this time, the given is the area or the probability, and we are looking for the value of z. So first locate the area 0.9495 on the z table. Okay, so that's the 0.9495. So earlier we're looking for the intersection, but this time we have the area. So we're just going to trace it back on the leftmost and then on the topmost to get the value. So we have 1.6 and 0.04. So therefore A equals 1.64. For the next one, so we're looking for z is greater than a. So since we have a greater than symbol, we need to subtract first the given area from 1, then locate the difference on the z table. So we have 1 minus 0.0071, that is 0.9929. Okay, so there you have it, 0.9929. Then again, just trace it on the leftmost and on the topmost. So you will have 2.4 and 0.05. So therefore A equals 2.45. Now let's have another example. So find the value of A if the probability of Z is greater than A at less than 1.52 equals 0.550, and probability of Z is greater than 1.03 at less than A equals 0.1364. So let's solve the first one. So to rewrite, we would have probability of Z is less than 1.52 minus probability of Z is greater than A. So let's rewrite everything. So probability of Z is less than 1.52 minus probability of Z is greater than A equals 0.5550. So the probability of Z less than 1.52 is equal to 0.9357. So if you would use the Z table, that would be the area. And then minus probability of Z greater than A equals 0.5550. So we're just going to solve it algebraically. So we would have 0.9357 minus 0.5550 is equal to the probability of Z is greater than A. So the difference between the two is 0.3807. So now we have the area, and we're just going to look for it on the Z table to find A. Okay, so since the area is less than 0.5, so we'll be using the negative part of the Z table. So the area 0.3807 has no exact equivalent area on the Z table. So we just have to get the closest one, which is the 3821. So just locate that one. So that's 3821. And then trace to the leftmost and to the topmost. So we have the negative 0.3 and 0.00. So therefore A is equal to negative 0.3. Now let us solve for the next one. So just rewrite it first. So we would have the probability of Z less than A minus the probability of Z greater than 1.03. So just rewrite everything. So we will have probability of z less than a minus the probability of z greater than 1.03 equals 0.1364. So if we look on the z-table, the value of z greater than 1.03 is equal to 0.8485. So we will have probability of z less than a minus 0.8485 is equal to 0.1364. So solving algebraically, we will have p or probability of z less than a equals 0.1364 plus 0.8485. So probability of z less than a equals 0.9849. So since that value is greater than 0.5, so we'll be using the positive part of the z-table. So the area 0.9849 has no exact equivalent area on the z-table. So we'll be getting the closest, which is the 0.9850. So we just have to trace the leftmost and the topmost value. So we have 2.1 and 0.07. So therefore, A equals 2.17. Okay, so we're done for today, and thank you very much for your time. I hope you learned a lot today. See you in our next lesson. Bye!